Hello and welcome to another NGen Math 8 lesson by eMath Instruction. My name is Kirk Weiler and today we're going to be doing Unit 5, Lesson 6, more work with equations of lines. So throughout this unit, right from the first lesson, we've been developing ideas like slope, how to graph lines, how to graph proportional relationships. In the last lesson, we really looked at things like lines that have negative slopes and ones that have negative y-intercepts. What we're now going to be doing for the last sort of few lessons of this unit is really practicing both how to graph equations of lines and then how to take graphs of lines and figure out what their equations are. This is really important material that will follow you throughout your time in math. Literally, no matter how many math courses you take, you likely will have to look at equations of lines, be able to interpret their slope, be able to interpret their y-intercept, be able to think about what their graphs should be, etc. So let's jump right into it and do a little bit of review, right? So the main form of the equation of a line is what we call the slope-intercept form of a line. And the reason we call that is because if it's written in this form, y equals m times x plus b, where m and b are both numbers, then m is the slope, literally how much y is changing divided by how much x is changing. And the number that's added on to the end is the y-intercept, hence the name intercept in the slope-intercept form, and that is simply the coordinate where the line crosses the y-axis, not the x-axis. There is no sort of like x-intercept that shows up in the equation. Don't get me wrong, most lines have x-intercepts, i.e. where they cross the x-axis, but that doesn't show up in this equation. There's two things that show up in the equation. It's the slope, right, which is the direction and the steepness of the line, whether it's going up, down, and how steeply, and then where it crosses the y-axis. So let's get quite a bit of practice with that in exercise number 1. Let me just bring this up to the top of the paper. Now this grid is going to have a ton of lines on it eventually. I apologize for that, but we need to kind of save some space, so we're going to put a ton in here. The next exercise, you're going to continue to use this grid. I'll put those lines on a different grid up on here, but this thing's going to be pretty crowded. So anyway, let's take a look at exercise 1. For each of the following equations, write the slope of the line in ratio form and the y-intercept. Then graph the line and label with its equation. All right, awesome. All lines really should be graphed with a straight edge. I may take some time if I'm trying to save some time to do them really quickly by hand through the points, but make sure that you have a straight edge at your disposal. Let's take a look at letter A, all right? So in letter A, I've got y equals 1/2 times x plus 3. The number that's multiplying x, right, is the slope, and that's 1/2. The number that's added on, that then is your y-intercept. So let's write those two down in their standard, using their standard letters. The slope, for whatever reason, we use the letter m for most of the time, and the y-intercept, we use the letter b. Now, we need to be able to interpret both of these things. The y-intercept's quite easy. 3 simply is the coordinate along the vertical axis, right, the y-axis, where the line crosses it. So for us, that's going to be right here at 3, all right? The great thing is that gives us a starting point, a beginning point, if you will, right? Think about like the origin as being sort of the starting line, right? And you're starting 3 units above it. Now, what does the 1/2 tell us, right? Well, the 1 is telling us the change in y, and the 2 is telling us the change in x. So what that means is that for every 2 units we move to the right, we're going to move 1 unit up, all right? And that allows us to plot a lot more points. For instance, this point is 2 units to the right and 1 unit up. This point, this point, this point, and this point. Now, certainly 2 points are enough to be able to graph any line, so we've got lots of points up there. I could put my straight edge up now and connect those. But keep in mind we can sort of, if you will, reverse the pattern by thinking of this slope as also being -1 divided by -2. That would tell us that we can go 2 units to the left and 1 unit down, 2 units to the left and 1 unit down. Eventually though, right, we kind of get where we're going. We've got our line, we take our straight edge, we draw a nice line through those points, and then somewhere we label it with its equation. And again, this is going to get rather messy on your grid because of how many lines you have. But we've got y equals 1/2 x plus 3. Now, in this particular problem, right, both the slope and the y-intercept were, if you will, kind of convenient. The slope was written already as a ratio. The y-intercept was a nice whole number, and we're going to make sure that the y-intercepts are always integers. They're not going to be, 2.5 or 3.25 or negative 5 1/8, anything like that. Now let's take a look at another one that might be, let's say, a little bit trickier. Y equals negative 2 times x plus 8. Now, in this case, again, the slope is negative 2. But we want that written as a ratio, and we can always take an integer and place it over 1, and that will still be the same number. So negative 2 and negative 2 divided by 1 are the same thing. This way, we can look at this and we can say, all right, the change in y is negative 2, and the change in x is positive 1, which means that for every 1 unit that we go to the right, we're going to go 2 units down. All right, as much as possible, when you write a slope and ratio form, keep the denominator positive, so you're always kind of moving to the right, and then the numerator will either be positive or negative, indicating that the line either slopes upward, like this, or eventually in this line will slope downward. Now, we also know that the y-intercept here is 8, so that's easy enough. All right, and now we can start plotting this line, right? We can put our y-intercept up there at 8. We can now go 1 to the right and 2 down. 1 to the right and 2 down, right? And again, if you plot enough points that you feel comfortable, you don't have to fill up the entire grid with them. You just have to get enough that you're pretty sure that when you draw your straight line through it, right, you're not gonna miss any points. Okay. And again, let's get some arrows at the end of that line to indicate that we know that it goes forever. And let's label it with its equation y equals negative 2x plus 8. Okay. Now, letter C and letter D, right? The slopes are easy to read. They're already in ratio/fraction form, but they also have negative y-intercepts. So let's take a look at letter C, and then we'll have you do letter D on your own, but let's do one more together, which has a negative y-intercept. Okay, in this case, our slope is a positive 3/4, meaning that the line is going to go upwards from right to left. That's my change in y, not my change in x. This is what happens when I try to talk and write at the same time. And my y-intercept is negative 3. All right, so again, just to reiterate, right, a slope of 3/4 means that for every 4 units we go to the right, we're going to go 3 units up. 4 units to the right, 3 units up. We're going to start or begin at a y-coordinate of negative 3. All right, now we're going to go 4 units to the right and 3 units up, 4 units to the right and 3 units up. Sometimes you can't fit all that many points on a grid before you have to bring out your straight edge and actually draw your line. But we've got enough now, I think. And we now draw our line. Let's get some arrows on there. Let's get some labeling. Y equals 3/4 x minus 3, and we're golden. All right, let me bring the grid up a little bit more so you can see our lines. So what I'd like you to do now is I'd like you to pause the video, tackle letter D, right, where you can read off the slope, negative 2/3, and the y-intercept, negative 1, and see what you have in terms of your graph. All right, let's go through it. So we've got our m equals negative 2 divided by positive 3. Again, keep that denominator positive if you can. So 3 units to the right, 2 units down, and a y-intercept of negative 1. So let's plot it from there. All right, we've got our y-intercept here at negative 1. I'm going to go 3 units to the right and 2 units down, 3 units to the right, 2 units down. I'm going to reverse the pattern and go 3 units to the left and 2 units up, just to get that one additional point. Seem to have lost my ruler. There it is. Let's bring it up. And hopefully you have a little bit of an easier time with your ruler than mine. Trust me, try a digital ruler sometime. Not the easiest thing on earth to use. But here's our line. Let me sneak its label in down here. Y equals negative 2/3 x minus 1. Just barely got it in there. All right. One of the many what are called fluency expectations for you in 8th grade, so something that you're supposed to walk out of this course with being able to do, is if you're given a line in this form, y equals mx plus b, you should be able to plot it and plot it very quickly, all right, by identifying the y-intercept, plotting that along the y-axis, identifying the slope, using the slope to generate other points so that we get our lines. All right. So let's move on. Let's do a little bit more practice because sometimes it's kind of hard to identify the slope and the y-intercept. So let's take a look at that. Sometimes it's more difficult to identify the slope and the y-intercept, but we can very often rewrite equations in ways that can help. So let's take a look at exercise number 2. Rewrite each equation in y equals mx plus b form and identify the slope and the y-intercept. Then graph the line on the grid above and label with its equation. Always label, exclamation point. All right, so to begin with, on your worksheet, you're going to have to graph it up on that grid above. I just reproduced the grid down here so that it's less crowded and I don't have to flip back to the other page to keep doing it. So let's take a look at this first one. I'm going to write this thing out a little bit larger so that you can really see it. Y equals x plus 4. Now, when you look at this, the y-intercept is still very easy to identify. It's 4. But what's the slope, right? That's trickier because it appears like there's no number that's multiplying the variable x. And there truly is no readily obvious coefficient, right? Coefficient is the number that multiplies a variable. There's no readily obvious coefficient that multiplies x. But the whole point is the number that sits in front of x kind of tells us how many x's there are. So if I have 2x, there's 2 x's. 5x, there's 5 x's. So what we can always put in front of the x, if there is no number there, is the number 1. Because 1 times x is still x. So I'm going to rewrite this now as y equals 1x plus 4. All right? Now the beautiful thing is that now I can say, oh, well, my slope is equal to 1, right? And in fact, what I can say is my slope is 1 divided by 1, and my y-intercept is 4. Now, lines with slopes of 1 come up a lot, so it's actually something that I want to kind of take a look at as we're graphing it out. And let's go to the board now and graph this line. Just like we did before, I'm going to plot my y-intercept there at 4. But now, my slope of 1 tells me basically, right, for every 1 unit to the right, I'm going to go 1 unit up. 1 unit to the right, 1 unit up, etc. Now, if you notice that what happens when I do that is I'm really just kind of going through the diagonal direction of the squares that are on my grid. All right, and again, I point that out because lines with slopes of 1 will arise often. Both in mathematics, in physics, in the real world, you'll see lines with slopes of 1 quite a bit. So we have to be able to kind of deal with them and deal with them quickly. But once I have this, right, then it's very easy to do what I've done before. Take my ruler out, get it in the proper position, and there's my line. Whoops, a little skip of my board there. This will now be y equals x plus 4. You could certainly also label it as 1 times x plus 4 or use the original. Now, one that's very closely related to a line that has a slope of 1 is something like this, where we have y equals negative x plus 6. Y equals negative x plus 6. And just like before, we can throw a negative 1 in front of the x, or better yet, just throw a 1 there. The negative is already there. So saying that I've got negative x really means I've got negative 1 times x. If x was 5, then negative x would be negative 1 times 5, or negative 5. Again, if there's no number sitting in front of x, you can always tuck a 1 in there, even if there's a negative. Now, slopes of negative 1 also come up a lot. So we want to make sure that we understand, sort of how to deal with those as well. So just like before, I'm going to say I have a slope of negative 1 over 1, which means now I'm going to go down 1 for every 1 unit I go to the right. And again, my y-intercept of 6 is really no problem. So let's graph this thing. We've got a y-intercept of 6. I'm now going to go to the right one and down one, right one and down one, etc. And again, I want to just take a moment before we draw the line here to point out that when you have a slope of 1, right, you're kind of going up through the diagonals of all the squares, and when you have a slope of -1, you're doing exactly the same thing, but going down diagonal through the squares downward, right? So it's very, very similar to this one, where you're kind of going up at what we would call a 45-degree angle, right, versus down like this one, where you're sort of going down at a 45-degree angle. All right, let's get that thing in there as well. Rotate my ruler a bit. Oh, great ruler work. And excellent. All right. Again, I want to label this with its equation, y equals -x plus 6. Easy, easy. Now, the last one we're going to look at here is a little ironic, all right? And the reason why is that this is what we started the unit with. You know, and what I mean by that is that we started this unit, graphing lines and equations of lines, with looking at lines that had equations like this, y equals a number times x. These were proportional relationships with the constant of proportionality, which we're now calling the slope, right there. So, you know, you could go back to what we did in literally the first 2 lessons of this unit. I think it was actually maybe the first 3 lessons of this unit, and go, oh, that's fine, you know, I've got a line, you know, that does the following, and you could graph it that way. In fact, you could just graph a bunch of coordinate points where the y-coordinate is 2 times the x-coordinate. But if we want to sort of, if you will, force this line to be in y equals mx plus b form, then the question is, what can I add on to the end of this that doesn't change it? Well, in these 2 problems, we were able to multiply by 1, and that doesn't change anything. That's what's called the multiplicative identity property, if you want a fancy name for it. You can always multiply by 1, and nothing changes. On the other hand, I can't add 1 on. I can't be like 2x plus 1. That's different. But you can always add a whole lot of 0 on. All right? There's never, ever any issue with doing something like this. All right? And once you do that, then what should be hopefully pretty obvious is that you've got a slope of 2. That was easy right from the get-go. A slope 2 over 1, and a y-intercept now of 0. And what a y-intercept of 0 is it just means that the line is going through the origin. Again, that's what we saw in the first few lessons was, you know, if we've got a proportional relationship, it's one where the line goes through the origin, right, and then has this constant of proportionality of 2. Here, though, in the context of y equals mx plus b, I now use my b equals 0 right there, and I go 1 unit to the right, 2 units up, 1 unit to the right, 2 units up, etc. All right. And then I'm able to draw my straight line. We can always kind of manipulate lines, or the equations of lines, so that they look like y equals, whoops, that's not what I wanted. I wanted to move the line, move the ruler, not the line. So here we go, and that's y equals 2x. Your grid is awfully crowded right now. I apologize for that. Sometimes it can't be helped. But we can always rearrange equations so that they fit that standard y equals a number times x plus another number. And we'll do that throughout our time graphing lines, which we're going to be doing in the next 3 lessons as well. All right? Now, anytime you're working with equations and their graphs, right, you want to be able to do 2 things. You want to be able to take the equation and produce the graph, which we worked on in exercise 1 and 2. But you also want to go in the reverse direction. And what I mean by that is you want to be able to take the graph and produce the equation. So that's what we're going to be working on next in the following exercise. Let's take a look at exercise number 3. Given the lines shown below, answer the following questions. Letter A, which line has a slope that's positive? How can you tell without first finding the slopes? All right, so I'd like you to think about this a little bit. You know, here I've got line A, here I've got line B. I claim that one of those 2 lines has a positive slope. By default, the other one's got a negative slope. Which one's got the positive slope? how can you tell? Pause the video now and make sure you can answer this very important question. All right. Well, first off, I hope you said line A. All right. Now, the reason or how you can tell it's got a positive slope, right? The way that you describe that is kind of up to you. To me, there's two good ways to describe it. All right. One way is just a purely kind of like geometric, hey, as I go from left to right along this graph, this line goes uphill. So if you said the line went uphill as you read the graph from left to right, that's awesome. That is a great explanation, no problem with that. The more technical explanation is that line A has a positive slope because as x gets larger, and that's really as we move from left to right, as x gets larger, so does y, right? So when we look at a graph, we should always read it like we read a page from a book, going from left to right. So if I start on this line and I go from left to right, I move uphill. On the other hand, if I start from this line and I move from left to right, I go downhill. And that literally means on B, as x is getting larger, the y value is getting smaller. They're moving in opposite directions, if you will, which means the slope must be negative for line B. All right, let's take a look at letter B. What distance separates the two y-intercepts? This is pretty easy. How much distance is there between the two y-intercepts? Pause the video now and see if you can answer this question. All right, well, it's pretty easy. Here's one of the y-intercepts, here's the other y-intercept. We can literally count, and we would see that there are 8 units. Right? Just 8 units to separate the two y-intercepts. Simple enough, right? One y-intercept's up here at 5, the other one's down here at -3, total of 8 units. But now let's get into what's really quite important. What are the equations of the lines? Now, we know, right, we know that the equation of a line can always be written as y equals its slope times x plus its y-intercept. So to write the equation of either one of these lines, we need to know two things. We need to know their slope, and we need to know their y-intercept. All right? The y-intercept is pretty easy. Let's take a look at line A. Right? For line A, right, this guy, the one with the positive slope, its y-intercept is -3. So let's write that down right now, right? B is equal to -3. Now, to figure out the slope for line A, though, probably the easiest thing to do is to grab a given point, and the y-intercept is a good point. Grab another point that's easy to see. Count how many units you'd have to go to the right. That would be 5 units. Count how many units you'd have to go up. That's 3 units. So the slope now, the change in y, which is 3, divided by the change in x, which is 5, right? So the slope of line A is 3/5, and it's amazingly important to be able to figure out what the slope of a line is if you're given its graph on a coordinate grid. Now finally, we just have to write the equation, right? Now that's going to be y equals the slope times the variable x plus the y-intercept. So at least at the beginning, you might write this as y equals 3/5 times x plus -3. Now, most people will not write the equation this way, and certainly if this was, let's say, a multiple choice question on a quiz, a test, a state assessment, I don't care what, the SAT in a few years, they wouldn't have it written as y equals 3/5 times x plus -3. What they would do is they would change this business into y equals 3/5 x minus 3. All right. So adding a negative is the same as subtracting the positive version of it. That's the way it's going to be written. I certainly, as a math teacher, would never take off on a student's test if I said, hey, what's the equation of this line? And they said y equals 3/5 x plus -3. I'd be like, hey, that's awesome. Great. Perfecto. Right? But from a multiple choice context, things like that, more likely the line would be written this way. All right. What I'd like you to do is pause the video now. okay? And try to figure out the full-on equation of line B. Be careful. Remember, it's got a negative slope, and that can be a little bit trickier, all right? But see what you can make of line B. All right, well, first things first, let's take care of the y-intercept. That's going to be pretty simple for line B. That's way up here at 5, right? So I'm just going to put down b equals 5. Awesome. Now let me go up and try to figure out the slope, all right? So if I take a look at these 2 points, right? This one that's at 0, 5, and this one that's at 1, 2, right? In order to go from one to the other, let me erase all of this ugliness and maybe just put a little blue dot there and a little blue dot there. To go from one to the other, I would have to go just 1 unit to the right and 3 units down. Now, it's very important, though, to be thinking about this as a change in y of -3 and a change in x of +1, all right? Keep your delta x positive, and then if you go up, like we did in this problem, the change in y is positive. And if you go down, as we did in this problem, the change in y is negative. Interestingly enough, both changes in y were 3 units, but the difference was as we went to the right here, we went down, versus as we went to the right here, we went up. All right, so again, you know, upon first kind of glance, you very well might write this equation as follows. Y equals -3 over 1 times x plus 5. All right, and again, that's a perfectly good answer. I've got no problem with that equation. Most of the time, again, if this was a multiple choice question, you wouldn't see the slope left as -3 divided by 1 because that can be simplified, right? -3 divided by 1 is the same as just -3. So most of the time, if you're talking about a multiple choice question or something like that, the equation of this line would be written as y equals -3 times x plus 5. All right? Very important skill to be able to take the equation of a line and take the graph of a line and change it into its equation. Let's keep going. Let's do one more problem. Here we go. Exercise number 4. A line has a slope of -3/4 and passes through the point 4, 4. Letter A, plot the line on the grid provided using point and slope. All right, great. So, you know, this is really no different than how we've been graphing lines all along. The big difference is that normally when we graph a line, we start with the y-intercept as the point that we know, and then we use the slope to generate other points. Here, this is the point we know, 4, 4, nice point, right? X and y coordinates are the same thing. And we know the slope, so we should be able to then plot the line from that information. Pause the video now and see if you can get this line graphed out. All right, well, we know the line goes through the point 4, 4, so why not? Let's plot that one right away. All right, we also know that the slope of the line is -3/4. Again, putting that -3 in the numerator tells me that my change in y is going to be -3, and my change in x is going to be +4. That will allow me now to go 4 units to the right and 3 units down to generate this point, right? 4 units to the right, 3 units down. Now, that's the only other point I'm going to get on this grid in this direction. So I may also want to think about this slope, even though I keep saying keep the numerator negative and the denominator positive, right? -3/4 can also be thought as 3 divided by -4, which tells me I'm going to go to the left 4 and up 3. So if I go left 4 and up 3, left 4 and up 3, I can generate some additional points. All right, I can now connect these. I can't quite label it with its equation yet because I don't know what its equation is. But we'll be finding that in a moment. So hopefully this was the line that you ended up graphing. Let's now take a look at what its equation is. So that's letter B. Write the equation of the line in y equals mx+b form. Okay, well, here's the beautiful thing. I've already given you the slope. It's -3/4. So see if you can finish it off and write down the equation of this line. All right, so let's do it. Right, we know that the equation of a line is y equals m times x plus b. We know the m is negative 3/4. The only question is what's the y-intercept, but that's sitting right here at 7. So y equals negative 3/4 times x plus 7. Now finally, and this is a very, very important last question for us, letter C. Does the line passed through the point 20, negative 9 justify? So if I haven't been as clear about this as I should have been all along, let me be very clear now. A point is only going to lie on a line if when we put that point into the equation of the line, i.e. we put in 20 for x, we put negative 9 in for y, if it makes the equation true. So basically, all of the points that lie on a line are solutions to this equation. I don't know why I'm putting solutions in quote. They really are solutions. They are coordinate pairs that make the equation true. All right, and we're going to work with that a lot more in future lessons, so you're going to get that down pat. But let's do it. Let's put negative 9 in for y, and we have to be careful, right? Because 20 is the x, negative 9 is the y, and let's just see if this equation then is true. All right, so here we go. I'm going to put negative 9 in for y. I'm going to put 20 in for x. And I'm going to see, does that make the equation true? Well, I'm not going to do anything with the left-hand side. On the right-hand side, 4 goes into 25 times. I now have negative 3 times positive 5, which is negative 15, plus 7. Negative 15 plus 7 is negative 8. Negative 8 is not equal to negative 9. This is a false equation, so that means no. This point does not lie on that line. If the point makes the equation true when substituted into the equation of the line, then the line passes through it. If it doesn't, as is the case here, then it does not fall on the line. Amazingly important idea about how graphs and equations go together. All right, let's wrap this thing up. We didn't see a lot that was new today, right? We already knew how to graph a line using its slope and its y-intercept. We saw that in the last lesson. We got a lot of practice with that today. One thing that was a little bit new today was then taking a graph of a line and figuring out its equation by determining the slope and the y-intercept from its graph. All right. The last thing that we looked at, and again, a very important idea, is how to test to see whether or not a point lies on a line with a given equation by substituting that point into the equation to see whether or not it's true. All of these skills we're going to get a lot of practice on in the coming lessons as we graph line after line after line. For now, I just want to thank you for joining me for another NGen Math 8 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.